Assalamualaikum.
Waalaikumsalam, Doktor.
Dengar clear tak suara saya?
Dengar, Doktor.
Ya. Okay, saya set up sekejap. Berapa orang baru ni? 1, 2, 3, 8 orang. 29 orang. Okay, so pagi ni kelas pertama. So, saya assume you dah print out apa ni you punya slide. So, nanti kalau saya explain dalam slide, nanti you boleh catat lah dekat apa ni you punya print out slide. Okay. So, sekarang tengah record ke tidak ni? This meeting was set to be recorded. Okay, tengah record. Okay, saya buka slide dulu. Tengok boleh nampak tak slide saya ni. Okay, so nanti kalau saya explain, kalau ada soalan you tanya sajalah. Okay, so suppose untuk chapter number 1 ni masih banyak apa ni nak katakan teori ataupun information. So you dengar, you cuba fahamkan lah, tak perlu apa ni macam mana, sebab dia tak ada calculation sangat. So you dengar, you cuba fahamkan, because kalau nanti midterm ke apa ke, soalannya dalam bentuk objektif. So dia berdasarkan what I call your understanding about the topic lah. Okay. Okay, saya cuba sampaikan yang terbaik. Saya harap kamu tak tidur lah. Yeah, ready?
Ready, Doktor.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. So in terms of title of our subject is the fundamental of energy management. So probably if we just based on the title of the subject, so most of the content will discuss about the energy management, how we want to manage the energy. Okay. Okay, chapter number 1 in terms of topic ataupun the main content of the chapters is about energy scenario, policy, regulation, standard and also the level. Okay, energy scenario, policies. So we will have numbers of policies related to the energy management, acts and also regulation related to energy management, and the last one about the standard and also the level. So the aim of this chapter actually we want to know what is the meaning of energy management, and also what we need to do in order to reduce the pollution, and also how to utilize the energy wisely ataupun efficiently. Okay. Okay, energy scenario, especially in Malaysia. Okay. Okay, so what is the global warming? So normally energy management try to minimize whatever pollution that occur nowadays, especially the global warming. So what is the global warming? Okay, as shown in the figures, we will have our Earth surface, our atmosphere, and also the black color region represent the space. So the solar energy from the sun will transmit to our Earth, where only 48% will absorb by the surface of the Earth. The rest, 23% absorbed by the atmosphere. 29% will reflect to the space. Okay, so our Earth will absorb 48% energy from the sun. The rest will go to the atmosphere and also to the space. Okay, but if we base on the activities of what we call industrial, whatever human activities in the surface of the Earth, the activity also will release heat, where only small amount of energy will transmit to the space. The rest will return back to the Earth. Okay, when part of the energy will absorbed by the GHG. GHG stand for greenhouse gas. Greenhouse gases. So we have numbers of gases that include in this category. For example, the carbon dioxide, CO2, CH4 methane, CFC carbon, fluoro, saya dah lupa, carbon, fluoro, nanti you google lah. Okay, so normally CFC ni daripada refrigerant, daripada aircon and so on lah. NOx, okay, nitrogen dioxide. Okay, so most of the energy actually absorbed by this gas. That's why the global warming actually caused by the absorb of the energy by the what we call greenhouse gases. Okay, so this greenhouse gases will form some sort like layer, a specific layer at the atmospheric pressure that prevent the heat transmit to the space. And this heat will, in terms of direction, will reflect to the Earth's surface. So due to this reason, the effect of this phenomena will cause the increase of the temperature, where the temperature is expected to be increased between 1.4 to 5.8 degrees Celsius. Okay, so we want to try to reduce this effect by using the energy management system. Okay, so if you look at the graph, so the graph shows the amount of CO2, which is the gas, the main gas that contribute to the greenhouse gases, where this gas also will absorb the heat, and this gas will remain in the longer period of time in our atmosphere. So if you compare from 1870 up to 2000, year 2000, so at the beginning, the amount of CO2 release is around 290 ppm, part per million. ppm stand for part per million. And in 2000, year 2000, so the value increased to 370 part per million. Okay, so normally the amount of CO2 will keep increasing based on the amount of activity that occur in the in our Earth surface. Okay, so this is general information how you can understand about the global warming. Okay, Weda, ada any question about the global warming?
No, Doctor.
Yeah. Okay. So the global warming actually caused by a few factors. First, due to industrial activities, especially the power station activities that produce electricity and also heat. So this sector can contribute to 31% to the global warming. Then next, caused by the manufacturing sectors, about 20%, transportation 15%, forestry, when we cut what we call the forest, so it will contribute to 6% in terms of global warming. Agriculture 11%. So in terms of effect, by through these activities, so the temperature of the earth will increase. The what I call the ice will melt, especially in the Antarctic and also the Arctic. So due to the ice melting, so our sea level will increase. So we also have certain part of the world, we will have the increase of drought season atau kemarau, musim kemarau. We will have what you call this one? Extreme weather, tsunami, the increase of flood, more rain, hurricane, and so on. Okay, and also we will have at a certain part of the world the increase of what we call the capacity of the rain and also the snow. So these are the effect what we call due to the increase of activities that cause the global warming. Okay, so this effect will make GHG, greenhouse gas emission, become critical for companies to mitigate risk by reducing their GHG emissions. So through this reason, many companies need to try to make initiative to reduce the emission of this kind of gases that cause global warming. Okay, so if you look in terms of GHG emission in Malaysia, so the GHG emission increased 62% in 2020 compared to 2005. Okay, so by looking at this pie chart, so the 60% come from the energy sector in terms of GHG emission. 13% come from LULUCF. So you try Google LULUCF ni apa? Okay. So ni lebih kepada land usage and so on lah, forestry and so on. Nanti you cari apa LULUCF. Ni bukan Lucifer LULUCF. Okay. Through the waste from the industry, from the household and so on, 12%. Industrial process 6%, and agriculture 3%. So which means the amount of GHG emission will keep increasing if we don't do something about the GHG emission throughout the certain sector. Okay, so the practical method for companies to meet their environmental goal is through a sustainable energy management program. So we need to conduct energy management so that perhaps the amount of GHG emission will reduce, and we will able to reduce the effect of the global warming. So this is one of the reason why we need to learn about the energy management. Okay, ada soalan tak?
No, Doktor.
Okay. Boleh saya tahu, cuba you screenshot you punya screen. Saya nak tengok macam mana you nampak macam mana. Pasal yang saya punya screen lain. Boleh tak? You share kat group sekejap, saya nak tengok. Salah seorang.
Okey, Doktor, kejap. Dah, Doktor.
Dah, sekejap. Ya. Okay. So apa ni, kalau you tengok nota saya, macam ni lah nota saya. So saya in term of sentences very minimal lah. So you need to write out whatever important information from the lecture. So you tulis sikit dekat lecture note yang you dah print out tu lah. Okay. Oh, dia nampak screen saja, dia tak ada apa ni yang seperti saya cakap tak ada. Nampak?
Masuk Doktor, muka Doktor ke apa?
Muka saya.
Ada. Nampak.
Ada di belah atas
Macam ni, Doktor?
Dia ada belah atas
Tak bawah.
Bawah, okey. Okay, boleh proceed? So mungkin hari ni kalau ikut slide mungkin sampai slide 23 macam tu. Tengoklah macam mana. Okay. Sebab bila lecture berkaitan dengan teori ni dia sikit dia macam berisik. Okay. Yeah. See. Okay, primary energy supply. Okay. So from the previous slide, so we mentioned that the energy sector will have, in terms of contribution to GHG emission, around 60%, which is the highest sector, the highest contribution to the GHG emission. So if you look to the graph, so the meaning of primary energy means the energy that we use to supply what we call for example, the electricity and so on, for the company, for the industrial, for the agriculture and so on. So the primary energy normally refer to the nuclear energy, fossil energy like oil, coal, natural gas, petrol, crude oil, diesel and so on. And also renewable energy sources such as wind, solar, geothermal and also hydropower. So if you look to the graph, so this graph actually refer to the actual data for the primary energy in Malaysia, start from 2000 until 2021. Okay. where the color of the graph represent, for example, the green color represent the data for the hydropower and also renewable energy. The blue color, the light blue color represent the coal and also coke. The dark blue color represent the natural gas, and the what color is this? Warna hijau apa ni? Apa ni? Apa ni hijau ni apa? Kalau perempuan tahu ni, warna kain ni apa ni? Turquoise. Turquoise turquoise color represent the crude oil, petroleum products and others. Okay. And the unit that used in this graph, if you look at the y-axis that mentioned here, KTOE represent ton of oil. Tak nampak sini. TOE represent a unit of energy defined as the amount of energy released by burning 1 ton of crude oil, which means amount of energy produced if we use if we burn 1 ton of crude oil. So 1 TOE represent equal to 11.63 megawatt per hour. Sorry, megawatt hours. Okay, so that the unit that used to describe the usage of energy in this graph. Okay, so we have KTOE. TOE stands for ton of oil equivalent, and KTOE means kilotons of oil equivalent. Okay, boleh faham tu eh? Okay, so in this graph, okay, so in the graph, I divide in terms of graph into two. So to simplify or to shorten the data in the graph. So first part is the data from 2000 to 2001, where you can see the value of in terms of KTOE for these different energy supply. So for example, at 2001, for the hydropower and also renewable, the value is 607 KTOE. And for the coal and coke, 2000 something. For the natural gas, 25,000, and crude oil, 21,000, around 21,000. So the highest utilization of the primary energy supply is come from the natural gas, and then followed by the crude oil. Okay. So indirectly, we know that these two kind of called primary energy will contribute to a greater amount of emission, pollution, and also the GHG emission. Okay, for the data from 2011 to 2021, if you look at 2021, the value is keep increasing for all type of primary energy supply. Okay. So still the highest amount of energy supply come from the natural gas and also the crude oil and also petroleum product. Okay, so this is the trend for the crude oil, the trend for the natural gas, the trend for the coal and also coke, the trend for the hydropower and also renewable. Okay, so don't confuse about the the position of the graph line. So actually for the data, if you just refer to the position of the line, you will say that the highest value come from the hydropower and also renewable. So for this graph, actually the data actually refer to the difference of the graph. For example, kalau you tengok dekat 2021 kan, you tengok dekat berapa tinggi graph tu, bar graph tu. Okay, for example, 2021 kan, you tengok yang turquoise, nilai dia adalah 25,000 kan. So you pergi dekat y-axis, dia lebih kurang 25,000. So kalau you tengok natural gas directly, kalau you pergi tengok dekat y-axis, dia lebih kurang you akan tengok berapa ni, 60,000 something kan. Dia bukan yang tu nilai dia. Nilai dia adalah the difference between what we call the point for the intercourse color dengan dark blue color. The difference. So that's why you will get 42,000 in term of KTOE for the natural gas. Sama juga untuk coal. Kalau you tengok kat sini, kalau you tengok directly at the exist, suppose at 2021 you akan dapat berapa ni? 80 something thousand. Tapi the actual reading actually 22917 because the value is equal to the difference. Okay tak? Faham tak? Okay. Sama juga untuk hydro power. You tengok kat sini 2021, kalau you tengok point dia, dia pergi dekat exist almost close to 100,000. Tapi dekat sini tulis 3,000 saja, 3,937. Sebab dia tengok the difference. Yang ni adalah called the presentation of certain type of bar chart. Dia ada beza sikit. Boleh tak? So, kalau keluar soalan macam ni, maknanya you kena tahu baca lah. How to extract data from the graph. Kita ada soalan tak yang ni, graph ni?
Tak ada, doktor.
Tak ada? Ada seorang je ke? Yang bersuara ni siapa nama?
Izatul Husna, doktor.
Izatul.
Izatul.
Lain ada tak ni?
Ada, doktor.
Ada, doktor.
Ada tak? Okey.
Ada.
Okey, bagus. Tidur Okay, so the primary energy supply. So the main primary energy supply actually is natural gas. Number 2, crude oil. Number 3, coal and also coke. And number 4, the last one is energy supply come from the hydropower and also renewable energy system. Okay, so if you look at the what we call the installed capacity, which is referred to the what we call the power station that use certain amount of different energy primary energy supply. So total actually this data I think is until 2021. So the total amount of energy that produced by different primary energy supply around 37,422 megawatt, okay, throughout the years. And the highest contribution actually come from the natural gas, the power station that use natural gas. Next come from the coal. Number 3, 55, 16.6% from biomass, I think. Sorry, hydro. From hydro, 60%, 16.6%. Followed by 4.5% for the solar. So that 1.2% from diesel. 1.1% from the biomass. 0.6% from the others. 0.4% from the biogas. Okay, so that is the pembahagian lah. Okay, different type of primary energy supply. Okay. Okay, the next pie chart represent the energy input in power station, which is different power station will use different type of primary energy supply, such as coal, renewable energy such as solar, such as wind turbine, fuel oil, diesel oil, natural gas, and also hydropower. So the main primary energy supplied to the power station is 62.1%, which is come from the coal. Okay. Indonesia banyak pakai arang batu lah. Okay. Sometimes combine with diesel engine and so on. Okay, ada soalan tak ini in terms of trend of primary energy supply in Malaysia from 2000 to 2021? So this graph want to show what I call the energy usage in Malaysia from 2000 to 2021, where this what I call trend also will contribute to the GHG emission indirectly. Okay, boleh? Kalau tak faham beritahu ataupun saya laju sangat ke? Okay. Okay, next. Electricity consumption, penggunaan tenaga elektrik lebih kurang cuma the difference in term of bar chart in this slide with the previous slide. So yang ni data dia bukan what call the value of the difference in term of value. So yang ni you can tengok pada exist. Okay. Okay, so the electric consumption trend by sector. Sector number 1 for residential, number 2 commercial. So residential represented by the blue, purple color, commercial, grey color, industrial, blue, light blue color, and for transport, represented by the what called blue circle, agriculture, red circle. Okay, so we have two axes here. Axis for KTOE. So KTOE exists. We need to use what I call for the data for residential, commercial, and also industrial. The second axis at the right side for the transport and also agriculture. The unit will be TOE. Okay, from 2021, 2000 until 2001, 2011 to 2021. Okay, for residential, so we will get the trend where the trend in terms of electric consumption for the residential will increase. For example, if you look in terms of value, KTOE, so the axis that you need to refer is the axis for the KTOE at the left side of the graph. So where for residential at 2001, the value only berapa ni? 1081, but if you compare to 2021, the value will be 3174. So the electricity consumption for the residential always increase. Okay, next for commercial sector also increase, but if you look at 2021, we will have slightly increase in terms of what I call the electricity consumption. Maybe nowadays the industrial sector, commercial sector already implement certain action in terms of energy management. Okay, and we have industrial where if you look at the graph, the industrial sector will use most of the electricity consumption, the highest what I call contribution to the electricity consumption. Okay, so if we base to the data for residential, commercial, and also industrial in terms of electricity consumption, industrial sector will consume highest amount of electricity compared to commercial and also in residential. Okay, so however for the transport that represented by dash blue line color, for 2021 the value is 3,000 something. However, for the agriculture, it's around 58,000 something. Okay, sorry, you need to refer to the which one? TOE. I call the axis at the right side of the graph. Okay, so this is the trend of in terms of electricity consumption. Okay, electricity generation mix by the fuel. So we have I call the portion for the coal, hydropower, renewable, oil, and also natural gas. Okay, electricity consumption by sector. So most of the electricity consumption come from the industrial activities. Okay. Okay, in terms of price, if you look for the world coal price based on USD value, so the green line represent the called the line for the current value, current price of the coal. So we can see that the trend, the price will keep increasing For the crude oil, also keep increasing. For natural gas, sometimes increase, sometimes decrease, depend on the market price. Okay. So due to this trend in terms of price, so the price of energy keep increasing. So this also include in Malaysia. Okay. So that's why the Tenaga Nasional in Malaysia, they cannot keep the price at the low price. Okay. So they introduce a certain mechanism that we call imbalance cost pass-through, ICPT. So what is the ICPT? So ICPT actually is the mechanism under the incentive-based regulation framework, which allow TNB to reflect changes, either increase or reduce in fuel and also other generation-related costs in the electricity tariff every 6 months. So dalam bil elektrik kamu, rate dia tak sama. So that's why kadang-kadang bil kamu tinggi, kadang-kadang bil kamu rendah. Because the TNB, they implement this kind of mechanism. So kalau there are two criteria that refer to by the TNB. First, the fuel cost. So if the fuel cost increase, your electric bill rate also will increase. Okay, so this based on the actual fuel cost, especially if the gas and also the coal price increase. And the second factor is referred to the generation specific cost pass through, which is referred to the agreement, purchase agreement, service agreement, and so on. If the purchase agreement or whatever content in the agreement increase certain service value in terms of maybe price and so on, so the electricity bill also will increase. So these are two factors that determine the price or the amount of bill that you need to pay every month. Okay. Okay. So for example, the graph show the cost change in terms of fuel price. So for example, the below the line x-axis bar chart represent the reduction of the cost, and the upper part of the bar chart represent the increase of the cost, especially refer to the fuel cost. So when the fuel cost reduce, so you will get rebate from the TNB that represented by the green color. So if the fuel cost increase, you will get surcharge, extra charge from the TNB. So that's why at certain after 6 months, the TNB will revise again the price of the electricity that you use, okay, for every 6 months. Okay, tak faham tak? So sekarang you punya tarif elektrik dia berubah-ubah tanpa you tahu. Faham tak? Dia bergantung kepada kalau harga minyak naik, you punya bil akan naik. Harga minyak turun, you punya bil akan turun. Kalau harga minyak turun, nanti you akan dapat rebate. Kalau harga minyak naik, you akan dapat kena bayar lebih. Ada surcharge. Okay?
Minyak sahaja ke doktor?
Apa?
Minyak sahaja ke bil elektrik tu?
Dia bergantung kepada, okay, for example, you ada steam power plant kan, yang hasilkan elektrik kan. Kena tengok apa yang steam power plant tu dia guna apa? Dia guna coal ke, dia guna gas ke, dia guna diesel ke. So kalau that particular power plant that produce electricity to our country, so for example kalau dia pakai gas, kalau harga natural gas naik, surcharge akan, the price akan naik. Kalau dia pakai coal, arang batu, harga arang batu naik, nanti charge dia akan naik. Sama juga untuk kalau dia pakai apa-apa jenis primary energy supply. Okay, so harga tu bergantung pada world market price lah. So yang tu bukan under kita punya control. Kita TNB dah implement that kind of mechanism. Ada soalan tak?
Tak ada doktor.
So maksudnya memang bukan minyak sajalah, mungkin diesel, mungkin natural gas, bergantung pada power station tu dia pakai apa, arang batu dan sebagainya. So kalau kat Malaysia, kalau you pergi dekat Jimah Contoh for example, kat Negeri Sembilan Jimahan, Jimah Power Plant, kebanyakan dia pakai arang batu. Okey. Apa lagi? Okey, ni apa? Banyak sangat graf Tak apalah, sabar saja. So yang ni apa graf apa ni? Yang ni graf in term of example, in term of energy cost, and also ratio in term of RM per kilowatt hours. So you tengok kat sini, ada yang monthly energy consumption rendah, ada energy consumption. Kalau you tengok kat sini, energy consumption rendah. So you tengok dekat bulan November, January ataupun January, tiba-tiba the price of the energy consumption increase. So probably during January ni mungkin TNB dia revise, dia tengok harga minyak sebagainya, so dia dinaikkan tarif boleh, tarif electricity. So that's why kita bayar lebih pada January until November. So dia consider ada kenaikan harga in term of fuel ataupun in term of agreement, ada perubahan in term of agreement TNB dengan certain parties. So harga akan naik lah. Okay, so the increase of monthly energy consumption in terms of RM probably due to the fuel cost increase and also the generation specific cost other than fuel also increase. Okay. Tapi yang ni ialah kita tak tahu, so macam tak tahu, mungkin orang boleh manipulate kan. So itulah. This is how the mechanism in terms of the change of electric tariff. So for our monthly bill for electricity. Okay, boleh? Okay,
Boleh
ambil
Doktor.
nafas minit. Ada soalan tak? Apa-apa selain daripada in terms of the content of lecture note pun boleh. Berkaitan dengan subjek pun boleh. Sementara sebelum saya masuk the next slide.
Attendance Doktor bagi untuk akhir kelas
Dengar apa? Sorry?
Attendance, kehadiran
Okay,
kelas.
attendance nanti for today class. So saya akan bagi normally for live Microsoft Team punya lecture. Nanti at the end saya akan bagi link untuk Google Form. Dalam Google Form tu you kena tulis nama dengan nama matrik. Cuma ada satu section, ada satu soalan. Nanti saya akan tanya soalan berkaitan dengan today punya slide. So you jawab je. You jawab saja, nak tengok siapa yang datang lah. Kalau orang yang tak datang, dia takkan jawab dengan betul lah. Okay, so nanti siapa-siapa yang jawab the best, nanti saya akan bagi badges lah. Jawab lebih tepat, bagus, saya akan bagi badges. Boleh?
Okey Doktor.
Selepas nak habis nanti lah.
Betul.
Ya. Boleh tak?
Pengiraan
Kalau, boleh tak you cakap you sebut nama dulu supaya saya ni tahu. Nama.
nama Faiz.
Faiz saja.
Doktor, pengiraan untuk megawatt tu kira tepat ke ataupun memang dia kira just best aspect je?
Macam mana? Pengiraan megawatt
Kiraan untuk tak setiap tahun.
Setiap tahun, dia setiap 6 bulan.
Setiap 6 bulan tu kiraan tepat lah tu.
Kiraan tepat yang tu dia mesti ada calculation dia lah, Kiraan tepat bergantung pada harga energy supply lah. Primary energy dia pakai apa dalam power station tu. Yang tu kiraan tepat maksud kamu macam mana kiraan tepat tu?
Ada dua. Kiraan tepat tu betul-betul tepat ke ataupun just dia bagi tahu just 6 bulan punya tu je? Saya tak betul sangat lah benda tu.
Untuk 6 bulan tu sama je lah. Untuk 6 bulan tu sama dengan kiraan tepat lah. Kiraan tepat berdasarkan apa ni meter reading kamu lah. Cuma sekarang nilai tu berubah dari in term of rate. Contoh 6 bulan lepas 1 kilowatt harga dia 20 sen. After 6 months dia reverse balik, dia kata minyak naik. Mungkin sekarang bukan 20 sen lagi, mungkin 30 sen. Faham tak?
Faham.
Pengiraan dia. So dikira untuk sekarang, contoh dikira kalau price tu 20 sen untuk 1 kilowatt, nanti bila 6 bulan lagi dia reverse balik, mungkin bukan 20 sen per kilowatt, mungkin 50% per kilowatt. Cuma kita tak tahulah, dikira kita percayalah kat TNB. Maknanya dia kira berdasarkan harga minyak ataupun harga energi yang betul lah. So macam mana kira saya tak ada detail lagi, saya tak tunjuk macam mana detail dia kira. Cuma tu dia proses. Dia mekanisme yang berlaku lah. Sebab tu kita tengok bil kejap naik, kejap turun. Kan? Macam tu. So sekarang ni apa you boleh buat? Kita kena untuk kediaman juga kita ada energy management. So you kena manage you punya electricity consumption lah. Kalau tidak, memang banyak lah. Kita baik.
Okey, biasa.
Okay. Ada lagi? Ya, terus sekarang pukul apa? Okey, kalau mungkin pukul 8.55 macam tu kita break sekejap. Kita cuba habiskan setakat mana boleh. Kita break sekejap. Kemudian mungkin kelas saya mungkin tak sampai 2 jam lah. Biasanya sejam setengah. Macam tu. Boleh Okay, so we continue with our slide. So energy management in terms of definition, goal and also objective. So what is the meaning or the definition of energy management? So energy management actually the strategy of adjusting and optimizing energy using system and procedures so as to reduce energy requirement per unit of output. So we want to reduce the energy while holding constant of reducing total cost of production the output from this system. Okay, so kita nak maintain production, kalau boleh production tinggi tapi amount of energy required minimum ataupun optimum. Okay, so that's what I call the definition of energy management. Okay, so we optimize on energy using certain system or procedure. Mungkin ada policy and so on. Dia guna what I call the system, specific system to control. Mungkin you pakai, instead of pakai typical energy from power station, normal power station, you can use the solar energy system, wind energy system and so on. Okay, so that the cost of electricity consumption will reduce for the same amount of output. Okay, the goal of the energy management. So the fundamental goal of the energy management is to produce goods and provide service with the least cost and least environmental effect. So nak kurangkan cost by reducing the energy consumption and also to prevent any environmental effect such as the global warming, the pollution and so on. Okay, so that's the goal of the energy management. So we have 3 main objectives of the energy management system. First, to achieve and maintain optimum energy procurement and also utilization throughout the organization. Kalau you ada company, yang ni nak fikirkan macam mana you nak optimum the usage of energy. Okay, so you can reduce the cost. Number 2, to minimize energy costs and also waste without affecting production and also the quality. So you need to think about how to reduce the energy cost and also how to reduce the waste that come from the production. And the last, to minimize the environmental effect. So these are 3 main objectives of energy management. Yeah. Ada soalan tak objektif? Boleh? So setakat ni boleh slide macam ni?
Boleh.
Boleh
faham
kata.
Yeah. Okay, ni goal and also objective. Malaysia perspective on energy management. So if you look at previous time, in the past factory management cited the following reason. So the previous I call the previous year, So the management of the company, certain company, dia beri certain reason why they cannot implement the energy management system to improve the efficiency of their company. So one of the there are few reasons. First, the energy price are relatively low because of government subsidy. So government bagi subsidi, so tenaga harga minyak atau harga electricity rendah. Jadi kenapa dia nak jimatkan elektrik? Penggunaan elektrik sedangkan harga murah, contoh for example. Okay. The first reason. Reason number 2, no proper financial scheme to help companies. So dia tak ada dulu tak ada, kerajaan tak bagi apa-apa financial support untuk diorang mungkin implement energy management system. So reason number 2, why the previous year the most of the company doesn't implement the energy management system. Number 3, the absence of incentive to encourage energy efficiency. Tak ada incentive, which mean contoh kalau company pakai energy management system, kerajaan tak ada bagi cukai pengecualian cukai ke, tak ada grant ke, macam tu. Okay. Number 4, regulation do not address or do not involve any energy efficiency. So dalam regulation punya, kerajaan punya regulation tak ada mention about how to reduce the global warming, how to reduce the pollution, and so on, how to use the energy efficiently, and so on. So that's why in previous year the company doesn't care about the energy management system, how to manage the energy. Okay, next reason, lack of support system to undertake greener measures. Okay, so tak ada support, especially from the government. Okay, so nowadays, however, efficient energy management is possible and profitable. So untuk sekarang dah banyak macam-macam sistem ada dan lebih menguntungkan sebab ada support daripada kerajaan. There are few policies that involve with energy management. So if any company implement the energy management system, so the government will give certain pengecualian cukai, certain support, certain grant, and so on. Okay, so the implementation of the ongoing energy efficiency program guided by the objective of the national energy policy. So ada policy help to promote efficient use of energy resource across all sectors. So involved with all sectors including the industrial, commercial, agriculture, and so on. Okay, yang ni apa ni? Yang ni adalah the intensity, which is referred to the quantity of energy required per output or activities. Okay, so we call the final energy intensity. This data, you tengok saja data, this is for PEI. PEI stand for primary energy intensity. The unit will be TOE per GDP. Okay, TOE is the amount of energy. GDP is the parameter that describe the economic growth. So if the GDP higher, which means the economic growth is better. Okay, so the ratio between energy supply and also GDP measured at purchasing power parity. Lower ratio indicate that less energy is used to produce 1 unit of output. So kalau saya tanya, kalau berdasarkan graf ni, nilai yang rendah ataupun nilai yang lebih tinggi lagi bagus in term of what I call energy intensity compared to GDP. Nilai yang lagi tinggi bagus atau nilai yang lagi rendah bagus? So the value actually refer to the ratio between energy use and also the GDP. Boleh jawab tak? Ni boleh tanya ni. Okay, so you tengok Okay, IEI represent the industrial energy intensity, so the energy that used by the industrial. So the value refer to the ratio between the energy usage and also the amount of what I call amount of money that produced or obtained by the industry. Okay, so kalau suppose kalau you tengok dekat graf ni, ratio lagi rendah ratio dia maknanya lagi bagus sebab kurang guna energi tapi output dia banyak. Kan? So kalau you buat bahagi X bahagi Y, kalau X tinggi, Y rendah. Contoh X itu energi, Y itu adalah amount of money output ataupun amount of GDP, GDP value. So kalau energi tinggi, GDP rendah, dia dapat ratio lagi tinggi ke lagi rendah? Energy divided by GDP, kalau amount of energy higher than amount of GDP, dia dapat ratio lagi tinggi atau lagi rendah? Boleh tak? Faham tak? 10 bahagi 5 dengan 5 bahagi 10. Mana lagi rendah?
5 bahagi 10.
5 bahagi 10 rendah kan? So maknanya ratio dia rendah kan? Okay tak? Okay, contoh.
Rendah doktor.
Okay, 10 bahagi 5, maknanya contoh 10 tu adalah energi. 5 tu adalah GDP. So energi yang dipakai lebih tinggi berbanding dengan GDP. So dia akan dapat ratio lagi tinggi. So graf kamu dia akan tinggi seolah macam tahun 2000 ni. Okay. Kalau energy usage kurang, contoh katakan 5, GDP output dia lagi banyak, contoh dia 10, so dia akan dapat ratio rendah. Contoh pada tahun 2021 rendah. So tahun 2001 in term of data lagi bagus sebab the company use less energy but produce more output. Boleh tak? Okay. Cuma for this graph, kalau you tengok di industrial energy intensity dia naik sikit. So maknanya still dia pakai energy yang banyak pada 2021. So that's why the graph if you compare to 2000 nilai dia lebih tinggi. Okay, FEI, the final energy intensity, the ratio between the final energy consumption and also the GDP calculated for the calendar years at constant price in purchasing power parity. So yang ni adalah nilai tenaga yang akhir sekali, termasuklah residential, commercial, industrial and so on. Okay, ada salah tak? Okay. Habis kat situ. Kan apa? Boleh tak? Kita break sekejap, pukul 9 kita start balik. Okay, now slide about the energy efficiency. So the short, the abbreviation that normally we use for energy efficiency is EE. So EE stands for energy efficiency. Okay. Okay, energy efficiency introduction. So we call the figure, the simple figure shows the represent the industrial sector. So where in the industrial, in the pictures we have a factory, we have a product warehouse, we have the power station and so on. So where from the industry sector, we expect that the economies will grow through the production of the industrial sectors. So we'll get highest value of GDP, so highest value of amount of money that produced through the selling of the products. And also at the same time, the industrial sector need to use the power generation. So where to provide the energy to the equipment, provide the energy to the transportation and so on. Okay, so due to this reason, the energy demand also increase, not only for the industrial but also to the other sectors. Okay, so our discussion is more concentrate on the industrial sectors in terms of electricity and also the fuel consumption. So if you look at the graph, I just want to show the the increase of energy consumption, amount of energy used from the industrial and also the different sectors. Okay, so for example, in this graph, we show you the trend of energy consumption for agriculture, residential and also commercial combined together, the transportation and also from the industry. Okay, so we can look the trend. So we can say that most of the sector will consume increased amount of energy consumption. So for every year. Okay. Okay. So specifically for the industry, we can say that the amount of energy usage increased from 28% to 33%. So actually this one I think is based on 2021 compared to 2005, I think. Okay. So the increase of energy demand will cause certain problem due to the fuel price increase. So if the fuel price increase plus with the energy demand, so that means the company, the industrial sector will need more money to purchase the energy, electricity, and so on. So the effect of this increase will cause the increase of the product price. Okay, so we need to pay more to buy something and so on. Okay, and also involved with the environmental problem, because when we supply more energy, so the power station will need to produce more energy, and also will use more coal, more natural gas, and so on, and will cause more GHG gas emission, CO2 gas emission to the surrounding or to the environment. So this is one of the problems involved. The second problem involved is the energy demand. Excessive of energy. So sometimes, for example, the power station produce 100 kilowatt of energy. So only part of the energy will use to produce the products. The rest probably will waste it. So this is the other problem. Non-productive use of energy. So this is the first problem. We need to combine with the energy management. We need to know how to use energy efficiently. Okay. So the solution of this four problems is by implementing the energy efficient system or the energy efficient policy and so on. Okay, so you need to use use the same energy efficient. It means that you need to use the same or less amount of energy to produce the better output, or using less energy to accomplish the same task or to enjoy the same comfort level. So basically, the meaning of energy efficiency, we need to reduce for the same amount of output, we need to use less amount of energy. Okay. Okay. Okay, so we need to maximize every unit of energy that we receive from the power station and so on. Okay, boleh tak? So general definition for energy efficient, so maknanya you pakai energy yang minimum, optimum, to produce the same amount of output. Okay, itu saja berkaitan dengan definition of energy efficient. Okay, boleh faham tak slide ni? Boleh? Ada soalan?
Tak ada, doktor.
Sekejap. Sekejap. Ada tak lagi. Okay, success story of energy efficiency. For example, Cargill Pump Product Sdn Bhd invest around 1.3 million on energy saving project that lead to 2 million in terms of saving per year in energy cost. So by implementing the energy efficiency system, energy management system, this company save around 2 million in terms of money per year, okay, in energy cost. Another example, Anju Steel Berhad decided to invest 40,000 ringgit for cost-effective energy measures and now save 6,581 gigajoule at the cost of 322,000 ringgit, coupled with reduction of 1,256 ton of CO2 per annum per year. Okay, so these are the achievement that obtained by this company. Okay, just by invest around 4,000 ringgit for the cost-effective energy measures. Okay, Kuala Lumpur Security Commission winner of the ASEAN Energy Award for energy efficient building and also become an example of technical know-how and innovative that meet world standard of energy efficient design and also function. So the building implement the green design in terms of building structure so that the energy consumption for that building reduce. Okay. Same goes to the building for the Ministry of Energy, Communication and also Multimedia, designed to showcase readily available and cost-effective energy efficient features. So in terms of the design of the building. Okay, Malaysia Energy Centre based on the zero concept. Ini zero concept bukan zero. Zero concept. The building aim to spearhead the realization of utilization of energy efficient and also renewable energy and become a national icon to promote in building energy management. And the last one, okay, ini as general, collectively, the 54 industrial companies audited by using the energy audit tend to save over 22 million annually by just implementing Malaysia Industrial Energy Efficient Improvement Project recommended measures. So kalau in total, kita boleh jimat 22 million setahun by hanya dengan menggunakan energy audit. So ada orang akan audit macam mana penggunaan tenaga dalam bangunan dan sebagainya. So daripada cara tersebut boleh jimat banyak bermilion setiap tahun. Okay. Ini example Okay, the benefit of energy efficiency. So first, monetary benefit, estimated saving of 1 billion in energy related costs for users, additional saving of RM 5 billion related to investment in utility infrastructure, save fossil fuel, so using energy efficiently save overall fuel consumption, extend the lifetime of the fuel reserve. So kalau you kurangkan penggunaan fosil, so nanti dalam reserve kamu in terms of source of fuel akan bertambah ataupun tempoh masa you boleh pakai fuel lagi lama lah. Okay, add up to energy cost saving for user, preserving the environment. So burning fuel, fossil fuel emit noxious chemical, dangerous chemical gases, and massive amount of carbon dioxide that cause health risk and also global warming. Okay, adopting energy efficient strategies reduce ton of these emissions that help protect the environment. Last one, improving foreign reserve. Successful energy efficient implementation translate into less money spent on imported fuel and less money flowing out of the country. For example, kalau you pakai solar power and so on, wind power and so on, so amount of fuel that you import from the foreign country will reduce. Okay. Leaving more to explore local resource that earn not deplete and also the foreign exchange. Okay, so these are the benefit of the implementation of energy efficient. Okay, ready? Energy efficient instrument. So we have by using the standard measures. So efficient technology at medium cost is key for realizing energy saving. Applicable across all sectors. High efficient motor, for example, by using high efficient motor, I expect to provide substantial energy saving over 500 million in terms of saving. Okay, so we can use specific pump in our industry. So how will the pump convert to useful energy from a hydropower source and also transmit it to the pump output. So yang ni adalah salah satu cara mungkin, salah satu example lah, salah satu cara you nak kurangkan energy consumption. Contoh, kalau company kamu guna banyak pump, so you kena cari pump yang lebih efficient lah. So dia boleh jimat lagi banyak tenaga. Okay, so we need to use energy management system. Short form dia adalah EMS. So EMS is a set of tools combining software and also hardware that optimal distribute energy flow between connected distributed energy sources. A low cost measure that can achieve 10% energy saving for industrial and also business and recover investment costs within 3 years. Okay. So mula-mula mungkin you kena invest sikit lah untuk beli sistem. Tapi dalam masa yang panjang, mungkin you akan dapat untung lah. Mula-mula mungkin dapat macam rugi sebab you invest untuk beli mungkin 100,000 in terms of price of the system. But mungkin dalam masa 3 tahun, you boleh recover balik lah. Okay. So national energy consumption decreased by up to 5% when EMS penetrate commercial operation. So bila this system implement by the industry, so we boleh jimat tenaga dalam in term of energy consumption around 5%. Okay, yang ni contoh schematic diagram untuk EMS where we have certain what I call software, certain system that control the amount of fuel, amount of energy usage, amount of waste that produced from the process and so on. Okay. Ini detail kemudian. Cogeneration potential, which means cogeneration is a system that produces heat and also electricity simultaneously in a single plant powered by just one primary energy source. Okay, yang ni, for example, kalau you go to the power plant, in order to operate the power plant to produce electricity, you need to use heat. That heat actually come from the fuel. Okay, so part of the heat will use to produce the steam and also to rotate the turbine and so on. However, maybe 30%, 40% of the heat will release to surrounding. So cogeneration system will reuse the heat instead of release to surrounding. We need to reuse the heat so that the heat also will generate the energy and so on. Okay, nearly all the thermal energy produced is not dissipated into the environment, but is recovered and reused. So this is the main criteria for the cogeneration system. So we need to reuse the heat rather than the heat released to surrounding. So by using this method, enhancing energy efficiency from 35 to 90%. So cogeneration reduce energy use and save fuel load by 20%. So kita boleh jimat tenaga ataupun fuel around 25%. Initially, high capital costs are offset by long-term gain in quantum of energy save. So kalau mula-mula you kena invest banyak sikit, tapi dalam masa yang panjang you akan dapat benefit. Okay, so ini example of schematic diagram. If we based on this schematic diagram, around 70 to 90% will get energy and also in terms of electricity and also heat. So this heat actually we can reuse in order to reduce the fuel consumption of the certain industry. Okay, apa lagi? Okay, masih setakat ni saja untuk hari ni. Ada soalan tak? So in terms of policy related to energy management, kita pergi next class lah. So saya cubalah explain sebab in terms of policy ada banyak sikit. Nanti saya cubalah explain sebaik mungkin dan juga mungkin saya akan masukkan certain aktiviti lah. So saya tak nak saya bagi lecture saja. So mungkin you sendiri ada aktiviti sendiri lah. Mungkin the next class mungkin kita buat berbeza sikit. Okay, boleh tak?
Boleh, Doktor.
Ya. Yes. Why? Okay, why do we need to manage our energy consumption? So you jawab, nanti you letak nama, you letak nombor metrik, you submit. Okay, so yang tu sebagai attendant kamu lah. So yang the best answer, probably you will get badges lah. Saya akan update badges dalam blog. Okay, boleh?
Boleh, Doktor.
Okay, saya bagi masa dalam, kita tengok soalan ni dalam 5 minit. Okay, you submit. Ya, 5 minit saya tutup Nanti in case kalau you tak puas hati apa ni lecture dalam online ni, you kena beritahu lah. Okay, saya fikirkan cara yang sesuai lah sebab online ni macam ni lah. Ada 14 minggu online. Macam ni cara dia. Cuma nak kena pelbagai aktiviti so that you tak boring lah sebab content pun boring sikit. Okay, siapa yang dah submit, you boleh left lah. You boleh keluar. Jawab biasa je, jawab biasa. Senang, soalan senang je. Tak ada jawapan betul salah, tak ada. You just bagi je. Saya nak tengok lah, you punya understanding saja. Ya? Okay. So boleh saya tutup sebab dia tengah record. So saya tak mau video tu panjang sangat. Okay, saya accept attendance kamu sampai 9.30 je. So kalau yang hantar lebih daripada 9.30, saya assume you tak ada dalam kelas tapi you hantar. Ya, sampai 11.30. Okay. Thank you. Terima kasih.
Thank you, Doktor.
Thank you, Doktor.
Sama.
Thank you, Doktor.
Sama.